The International Space Station's Environmental Control and Life Support System, known as ECLSS, provides clean air and water to the crew, making life aboard the space station possible. It also serves as a unique testbed for the kinds of life support systems required for deep space exploration, long-duration space missions, and sustainable human habitats beyond Earth. The space station's ECLSS has been in operation since 2001 and has been regenerative since 2008, but is derived from technology that goes back to the start of the space program. The NASA space missions of the 1960s were some of the first to use life support systems, but they were only designed to be used once and then discarded. Skylab was a space station adapted from the third stage of a Saturn V rocket used in the early 1970s. It utilized a more advanced ECLSS system with stored water and oxygen, carbon dioxide and humidity removal, and fire detectors. The space shuttles, while reusable vehicles, still relied heavily on the use of consumables, which limited the time astronauts could spend in space and required expensive launches of fresh resources. It wasn't until the space station that a regenerative system became realized. Chris Brown, ISS ECLSS Integration Manager, says, achieving this highly closed-loop life support system is the culmination of years of development and is enabling technology for deep space missions. This level of recovery would not have been possible without the testing and operation on ISS. ECLSS consists of 3 interconnected components: the air revitalization system, the oxygen generation system, and the water recovery system. The air revitalization system maintains cabin pressure, temperature, and humidity levels. It also filters particulates, microorganisms, and volatile gases from the cabin air, and removes carbon dioxide from the cabin. The oxygen generation system produces oxygen through electrolysis. It breaks up water molecules from the water recovery system into hydrogen and oxygen. The oxygen is then pumped back into the cabin. The hydrogen is either vented into space or combined with the carbon dioxide exhaled by the crew and sent into a Sabatier reactor to create water and methane. The water is pumped back into the system to be used by the crew, and the methane is vented into space. The water recovery system captures and recycles wastewater from the crew's breath, sweat, cabin humidity, and moisture through special air conditioner. Before it is returned for use on the space station, the recycled water must meet stringent purity standards. The system also reclaims water from the crew member's urine, which it sends through a urine processing system. In 2021, an additional brine processor was added to the system, which extracts even more water. NASA now has demonstrated the ability to recycle 98% of the water collected from the U.S. segment of the station, enabling substantial cost savings and getting one step closer to long-duration expeditions. Together, these components create a complex regenerative life support system for closed environments. Brown says it's a wonderful collection of a bunch of very different technology, all put together to make an environment livable. While there is still more work to be done to make the system even more efficient and reliable for long-duration missions, the progress on ECLSS is an exciting testament to the power of human ingenuity, cooperation, and perseverance. It continues to breathe life into NASA's goals of sending people beyond the reach of our planet.